In this video, we're going to talk about Lewis structures or electron dot formula. You could hear them referred to both ways in your general chemistry class. So let's just jump right in. We want to know how many valence electrons do I need to draw this Lewis structure that I'm about to show you. What we're going to do is the hydrogen fluorine that's coming straight out of your handout. The very first thing I want to show you is your periodic table of elements. Now, your periodic table of elements, your group numbers dictate how many valence electron each element within that group is assigned. Okay, so your group numbers, they run 1A, 2A. You're going to skip your transition metals, and we have 3A, 4A, 5A, and so forth. So now you have an idea of where I'm getting the numbers for the valence electrons. Let's go ahead and draw it and see what we can come up with. So the very first thing I want to note is I have a hydrogen fluorine. That's straight out of your handout. Your hydrogen has 1 valence electron. Your fluorine has 7 valence electrons. I add that together. I'm looking for a total of 8 valence electrons between the hydrogen and the fluorine. So if we draw it out, I have a hydrogen and I have a fluorine. Remember, I said my hydrogen has 1 valence electron and my fluorine has 7 valence electrons. Well, if you have read your handout, you know about the octet rule and how most of the elements on the chart want to follow an octet rule. There are some exceptions. If you are confused about the octet rule and any of the exceptions that you see in your handout, you can go find the octet rule video in the video library, and that might be able to help you out a little bit. So if you don't see the octet rule video in your video library, just ask your instructor and they can get it put into your D2L for you, no problem. So what we have here is we have 8 total valence electrons, which is exactly what we're looking for, but we are not done, because what's going to happen is that fluorine is so electronegative, it's going to pull that hydrogen over to it, and now they are sharing an electron, right? They're sharing a pair of electrons, and that's that yellow one at the top and the green one at the bottom. And the reason I wanted to show you this is because how we represent those two lone electrons, or the one bonding electron pair, is a single dashed line. Okay, it's a single dashed line, and that's how we're going to represent that. So let's do another one. How many valence electrons do I need to draw this Lewis structure? Well, we're going to go back to our periodic table, and we're going to concentrate on the CO2. Now, if you look, your C, which is your carbon, is going to be in group 4. And then your oxygen is in group 6. That means that we need 4 valence electrons for our carbon, and we need 6 valence electrons for our oxygen, but there are 2 of them. So we have to multiply 6 by 2. That gives us 12. We're going to add 4 and 12 together. That means we need 16 total valence electrons in order for our Lewis structure to be correct. So if we have CO2, we're going to write our elements out. We have C in the center. We have an O on either side. Okay, C in the center and an O on either side. The very first thing we're going to do is we're going to connect them with a single line, not a dash line, but a single drawn line is what I'm trying to tell you. So after we do that, we're going to distribute our valence electrons. Now, if you look, we've used 4. That means how many do we have left? 12. So let's place them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So we have 2, 4, 6, 8, 10, 12, 14, 16 total valence electrons, because remember, these solid lines right here represent 1 valence electron for that oxygen and 1 for that carbon. Now, looking at this, if we're following that octet rule, does everybody have an octet? Well, both of the oxygens do, but that carbon doesn't. So that's why you see the different colors in the valence electrons. I just thought it would be easier to show it to you this way. So let's just flip on over to the next one, and we're going to do it again. Okay, so we're going to go ahead and draw our lines that connect our elements, and we'll go ahead and place our valence electrons. All right, now that we've done that, and we're trying to get carbon to an octet, what we're going to do is we're going to go ahead and remove 2 of those valence electrons from each of the oxygen and add a single bond line between the oxygen and the carbon, between each oxygen and each carbon. Now, if we count, everybody has an octet. Both of the oxygens, they have 4 valence electrons and 2 single bonds, which are 4 valence electrons. And then on the other side, you have 4 valence electrons, and the oxygen is bonded to that carbon by 4 valence electrons. That makes 8, so we're an octet, and the carbon has 4 single bonds, which is represented by 2 valence electrons. That means 8. So everybody's following the octet rule, everybody's happy, and we're moving right along. So let's just do another one real quick and make sure that we're understanding just the basis of the Lewis structure and how we're getting there. So again, let's look at the periodic table. I've explained to you how the group numbers work and where we're coming. So this one, we're going to do a PCl3. So you have a P of phosphorus, and that is in group 5, and your Cl is in 7. Okay, so for your P, you're going to need 5 valence electrons, and for your Cl, you have 7 of them. 7 valence electrons, but there are 3 of them, and so that's going to be 21. So you're going to take 21, add it to 5, and that gives you 26 total valence electrons. That lets you know exactly where you need to start. So if we're doing PCl3, I'm going to go ahead and put elements down, and then I'm going to connect them with a line. And once they are connected, then I'm going to start distributing our valence electrons. So we're going to go ahead and make sure that all of our outer elements are happy with an octet. And there we go. So all of our outer atoms are happy with an octet, but our phosphorus in the center only has 6. How many have we used? Well, we used 6 when we drew the lines, right? 2, 4, 6. And then let's see what we have in our outer atoms as the valence electrons. So we have 6, we have 8, 10, 12, 14, 16, 18, 20, 22, 24. So we're actually missing 2 valence electrons because we know we need 26. So because each outer atom has a full octet, we're going to go ahead and add those 2 that we know that we need to equal our 26 valence electrons to our central atom. Okay, so now if we count, we've used 26 valence electrons. That puts us right where we need to be. I hope that this video has helped you in some way just to understand Lewis structures in general. There are several rules that go along with it. You can find many videos on molecular modeling and all the ins and outs of it that break down specific rules, octets, exceptions, all the things. If you have questions, direct them to your instructor.